I prepared 4 or 5, I'm going to be quick, 4 or 5 slides, mostly to tell you guys my ignorance and what I expect from this round table to learn. So, what I want to learn, first of all, let me explain what is the purpose of this round table that we organize. One thing is to keep people inside all together. So it's very practical. Before lunch, they are tired, they go to different rooms. Now it's a great opportunity to meet again and discuss some, whatever we want to discuss. Apart from that is fostering interdisciplinary dialogue, whatever that means. And I'm not going to spend time explaining it. Connect institutions across countries and continents, because we can, this is my seat. In Greece, we have a proverb, so you don't leave an empty seat, because you're going to be filled quickly. And especially if you are in government sector. And of course, because today I'm watching you, I'm the big brother, especially in the natural science that I follow. There was some presentation, and if I want to do a study in the future, I like to connect the institutions and the countries to your views. I mean, it might be interesting. And engage academics with extensive teaching and research experience. This is a polite way of saying we invite usually old people. When you have some extensive experience, that's what it means. Okay, I have very extensive experience now with research, whatever, policy making and all this. Now, I use the word aporia and I define what it is. This paradoxical, there are many words. Aporia is Socratic. Aporia means aporia. It means I don't have the resource, whatever the etymology of that is. But here they have many meanings. It's a question actually. But paradoxical findings, unresolved tensions, or fundamental uncertainty. I got this definition from ChatGPT. Unashamedly, I'm using ChatGPT, okay? But very critical. And I have published 3 papers which are called dialogues with ChatGPT or the artificial intelligence. So what are the key trends in science and engineering that will shape the future? If you knew it, you would become a billionaire, but anyway, I'm not. But let's see. How can a holistic approach help? Again, I define what holistic is, the entire. I'm impressed. I always, since I was young, I tried to find physics help sometimes to find a theory of everything. That would be very good if we had a theory of everything and we include economics as well there. So is that possible? And what is the role of STEAM in the future of science and engineering? That's my third aporia. Is there any role? I like that they added the word A. It used to be STEM or whatever you pronounce it, but now it's STEAM, which includes art, and art includes architecture as well, as some people have said. And this is important. And there's another dimension, 4 dimensions. Aporias, next time I'll use this 4-dimensional approach. Where does ethics fit all of this, into all of this? Thank you very much. I'm going to invite the first speaker. You are the first speaker.
I think so, yeah.
Always I'll put you first. I don't know why.
Thank you.
No, because I'm more beautiful than you, so people can compare. And
I saw okay.
And I put you in the wrong. Okay, so our first speaker is Professor Bala Maheswaran, whatever I recall. We have the pleasure to have him helping us with the engineering division. And he will speak for less than 10 minutes, starting now.
That's a big problem. So guys, let me start with this one. Okay, I'm just going to set the stage for this discussion, science and technology, why this is so important. So let me start with this slide. Who made this slide? I asked AI to make a slide, so it gave me all kind of titles. Can you see? Distinguished professor, distinguished member, that one, this one, all kind of things. But that is true too. Right? So I am Bala Maheswaran from Northeastern University, Boston. So let me very quickly introduce a couple of things. Okay, always I want to give a little credit to my institute. I'm from Northeastern, it's in Boston located. It's a huge institute. And you can see we have about 100,000 applications last year with about 25,000 graduate students and approximately 25,000 undergraduate students. The important part is not the number of applications, we only admit 5% or something like that. The yearly tuition, people willing to pay and come there. That's the most important part here. Also, these are things I showed you in the past. Maybe, we invite big people, to this, and this is our commencement at the Boston Celtics. So now we are much larger, so we are moving to the baseball stadium. All right. What is my connection to this global study and global whatever we call, right? Because last year and the previous year, I did a program in Greece. This is called Evolution of Scientific Thought and Technology Abroad. This we performed that one in Greece. You can see, again, I make sure to put my hat there, Northeastern hat, to take a picture with this Acropolis to promote that both, right? So I'm trying to connect this one with you guys. So we went to so many different places. I don't want to get into that detail. So I have a lot of kind of involvement with these global studies, right? I did this one. Also, we were very happy. You can see the person is about to jump, right? That's me. And he was actually in the air this time, right? So because it's a very enthusiastic, interesting program. Now, before this one, in the USA, we did a similar study that at Silicon Valley. How many of you are familiar with Silicon Valley? Most of you. It's the ground zero for technology innovation. Technology means science and technology we are talking about. So I pretty much took students to Silicon Valley, spent a lot of time there. We visited so many big companies like Intel, AMD, Nvidia, Tesla, VMware, all kind of things. Right? We went inside, took pictures and learned and spent time with them. It's a very well connected program. So I did that one alone. The previous one I did with another professor. Again in Tesla, in front of Tesla, you can see me here. This took in 2019. I was in there. Then I saw the guy who found Tesla. He was jumping too on the stage. Can you see that? How many of you know this guy? All right. Because he copied me. That's the point. Okay. No, I'm not promoting. I'm saying they copied us. So here's the thing. It's a famous company. I'm going to get to the point. Okay? It's a famous company in the USA. Most of the computer you use the chips. Okay, Intel chips there. So we were there. You can maybe identify me somewhere. We were inside. Of course, normally we don't take pictures inside because they don't want to show their business secret. So we took the picture outside. You can maybe locate me somewhere here. Is that right? So I want to ask you something. I put a square there, the top of the building. Something I noticed that when I want to get your feedback, what do you see there? A lot of birds, pigeons. Can anybody tell me? Give a little hint. We have to move fast because I know Gregory, he's going to bring that, but somebody please take the
Lights.
lights, lot of white lights. Is that right? That is the one. Intel is a rich company. Okay, they are money-wise, they have no problem at all, right? They make chips, sell it for $400, $500 from sand, things like that. Look at this one. What is it? This light?
No.
It is wind fan. What's the purpose of that one? They want to generate their own electricity and make a zero energy building. So this is a rich company. They have so much, a lot of money, but still they focus this environmental issue, sustainable issue. That's the focus here. Okay, now I'm going to ask you another question. What is the cost of a terabyte? That means one TV, which is equivalent to 1,000 gigabytes in 1964, but I'm going to give you a hint. Now you can buy 1 terabyte for $35. This is in my pocket, right? I got this one at the conference that they give free sometime. It's 30 gigabytes. 1,000 gigabytes is 1 terabyte. This is 30. That means the cost of 1 terabyte I'm asking you, currently you can buy, go to this big store, you can buy 2 terabyte for $70, $65, things like that. Depends on the time and sale. Now, what's the cost in 1964?
More than 1 million.
$3.5 billion. Right. Guys, 1 terabyte means, this is 33 of them. That means one of this cost $100 million. I am carrying this one in my pocket. Can you see? It's $100 million in my pocket. Sometimes at conferences they give certain things free. Right? Why? How did we achieve this one, get into the stage? That's the point I'm trying to make. Because of technology. Because of technology, we were able to bring this 3.5 billion to whatever. I'll show you the price currently. It's about $27, $30 ballpark. Can you see the difference? It's all technology and science. This forum, whatever, this long table is about technology and science. Let me get into the next stage of this one.
You have 3 minutes today and in 1964. Remain the same.
Okay. Now the technology changed this way because the problem is before we have to use big transistors, wall mounted transistors and things like that. Gradually we changed that one to integrated circuit with all these latest technology. Because of that we can put multiple layers and millions of transistors there. So we achieve a lot of things because of technology. Now so many things we can solve. We have a drinking water problem, we can solve that. We have carbon problem, we can solve that. No, yes, it's moving this way, but we believe. Okay, who is this guy? This Bala Maheswaran. Why this diagram is here? I am interested in writing a book. It's a I have published tons of papers. If I click on that one, I don't want to click now and just if I get time, I'll show you that later. So I want to write a book in project-based learning. It's like a reference book. I collected all the articles and things. It's simply combine, I have to put things together in time. So that is my information, background information. Now,
1 minute.
no. So here's my talk is about this one, this particular thing. Last June, I published a paper at another place. This is Cultivating Global Citizen Through Engineering Education, a framework for sustainable development. Right? So I want to say a few things about, this global citizen and global education, how to, produce global citizen, to contribute for whatever. So I saw this slide this morning from one of our presenters. Okay, this is the SDG goals, most of you are familiar with, right? So we want to achieve this one, can be. But, so these are the summarize those goals. That there's another major institute in the USA, it's called National Academy of Engineering. They established 14 grand challenges. These are the challenges. That's the meaning of grand challenges. Simply they want universities to produce engineers to deal with these type of things in the future. That's the meaning, right? They established this one, so we have to prepare. Now, there's a technology forum. It's a big people get together. They believe that we can achieve things. If you don't believe that you can't do, like I showed you this little transistor technology changed the price from 3.5 billion to $35, right? So they think that we can get rid of carbon. Believe that we can store energy. Energy storage is the hardest part. We can do that one, lot of things we can, do it easily. And we can, I don't get into the medical side, we can come up with the clean water issue. Right now we have this technology, all the technology. What's the problem? In 1964 we had the technology for storage, but it's very complicated, costly. Currently we have technology for these things. Only thing you need to bring that cost down, make it more, creative and efficient. That we can do by producing future global engineers. Why? Because so many things are changing. Global economy is changing. Currently, there is a G5, group of 5 and E5, emerging market. Currently they are dominant, they are down. They are predicting this is going to take over this one. Because of that, there's a huge population change. Because they think India is going to take the lead in population, 1.7, then China, then Nigeria, Pakistan, in this order. All this technology, we need human resources.
But you are over.
Okay. So we need to come up with.
Exactly, and I like this idea.
Next time I'll come up with 2 slides. Okay.
Yeah. So we'll give you the opportunity even tomorrow, I mean, during lunchtime.
Oh, well, I'll come next week.
Or next week, yes. Okay, our next speaker is a newcomer to our institute, Mina Pelegri, correctly? Or Pelegri?
Pelegri.
Pelegri. And she is from Rutgers University, and she will talk about AI.
Okay.
And she has 10 minutes to impress us.
So thank you very much. So what I will do is I will present you some thoughts, but also we have here I'll give you some results from what we had discussed last year in the Northeast Chairs meeting in the United States. So basically we had a similar kind of questions. So what is the current status for AI, right? So we all know that we have a growing awareness of how AI technology is receiving, of course, in industry innovation, but as well as education. Especially the academics here, we have a fear about not only taking our jobs, but also a fear about what we are teaching our students. So I will add to that for us to be using actually the AI as a tool to further academic and professional excellence, so that actually for all programs and for all stakeholders, so that actually we can grow together. We had a couple of discussions in the previous session about that. So first thing was, okay, let me ask open ChatGPT, what is the contribution of AI in engineering, research, and education in one statement? Okay, so this was a response from there. So enhances teaching, of course, and research. How? By personalization, automation, and accelerating innovation. These are the 3 things that actually is provided back. This is from OpenAI. And of course, it had through intelligent data analysis, simulation, design, optimization. So if you have worked with AI, of course, you know that basically it averages whatever is out on the internet. So the intelligent is with a grain of salt, because you can always get an average response, but that would be an average response. So we're getting better with more data that are in there. Simulation and design optimization, they're still actually growing, but they're doing by far better from the intelligent data analysis. So in innovation, what we do, it automates design, optimization for sure. We have kinds of these things, and repetitive tasks. For example, I give them tables to actually combine, or I use ChatGPT to basically create skeletons of talks and things of the like. Everybody's, I hope, they're using that. Ensures data accessibility. Sometimes I'm trying to find new references that I don't have. I may have read like 20 papers on a topic, but there are another 2,000 there that are out there, right? So basically, it can provide very fast this information. Solution discovery improves data accuracy. Well, the improves is the greatest result, as we said before. Real-time data from various sources. We have used that in all mechatronics courses, and it's very available there. Of course, it is in industry too. And it has creativity, efficiency, and sustainability. All of those, of course, are when they are critically used. When you critically use the right, not right, but actually ask the AI software the right questions, or you create layers in that. If I am an instructor, how can I use that? Personally, I have used it for automation and personalization. I have just, make sure that it helps me on grading student homeworks, or on creating, like personalized tests for students. I see sometimes that the student has a problem with a certain issue, or is a certain topic. I will go back and create more and more and more in-depth kind of questions for the student to help them out. Intelligence, basically, I can use AI to find out, like similar topics in other universities. Like MIT has the open access, like courses that they offer. I can drill down there without me spending about 5 hours in doing that. They can do it in 2 seconds, provide, the material that is there. Of course, the idea is behind that you will have to be checking all of this information that you get. For students, well, except the known kind of access that the students have, if it's a critical student actually wants to learn, they can use it for 3D modeling. They can use it for writing codes, checking codes, right? I mean, of course, you know the structure, then you just say, okay, debugging. Like, you can do that very easily. Learning supported personalization. They are using it all the time. I know that they have access to, as I have access to all the courses, they have access to all the courses, right? And a lot of times, especially after the pandemic, we don't see the students coming to class because what they do, they sit back home, they open everything, like through either AI or through Google or whatever, they find all the courses, like, oh, I know that, I have it. Definitely I know how to solve this. They sit home, then they come to the classes, and then they fail exams. But that's a different story. Communication, academic, productivity. We have, at Rutgers, we have put a lot of access to this, as well as the coding up here. Because, the technical writing, like, we are of the school. I have been undergraduate director 10 years before I was chair. So technical writing was one of the holy grails. Engineers don't know how to write. In Greek, in English, in German, I don't care from which country you are, they have problems. So we were putting a lot of pressure there, and now I'm thinking as a chair, I'm like, okay, do I need the students to really be excellent in technical writing? I mean, in all reality, AI can provide templates of the reports. I need them to be able to analyze the data so they don't give garbage responses, right? I mean, be more intelligent rather than basically doing a perfect technical writing. The cat is out of the box for AI. Already, we know that it's going to be there. We cannot bring it back, so we better have to start learning how to use it and how to make our students intelligent enough and critical enough in their thought process so that actually we can use it in an efficient way. So, technical writing, they're using it a lot, presentation designs, grammar, and all of these things. I mean, we all know how this is there. So this is an example. I mean, ChatGPT. And this is from, actually you can find this, but I have asked the same question in class. I'm doing senior design right now. So, on-time training. Definitely they open up the internet, they open up AI, ChatGPT, whatever is there, they get all the information. Tasks remembering, follow-up actions, basically, okay, I have to do this today, make me a schedule for this. Records, handling large data facts. The facts, again, is under question mark, right? So there should be a critical, all of this is offered to them, but there should be a critical component in there. So just to give you a taste, AI in engineering education right now, as of perhaps like a week ago, university AI degrees, they're about to have the graduate programs in US and about to have class graduate programs in US only. Internationally, it's more than 700, about 750. 744, only the UK, right? I mean, there's crazy amount of training that is going on right now in AI. Online certificates and MOCs, I mean, massive open online courses, these are huge. Like, almost every university has this, right? I mean, we're doing that also the online training. Whatever it's there that is not secure, forget it. It's already on Ether. It's already out there, okay? 500 plus platforms. This is millions of students, millions of people. And then you have corporate and educational partnerships, IBM and other projects, I mean, Hewitt. There are so many companies that are out there that are trying to do all of this. So, when we met last year at the 8th Annual Northeast Conference for the Mechanical Engineering Chairs and Heads, we were like, okay, so AI was one of the big things. I mean, I'm pretty sure I know it's going to be this year, but that was last year, okay? So how we reshape the overall landscape in mechanical engineering education, how we can use it, how we incorporate it so that actually our students, like they can use it as a tool rather than actually rely on it for answers. How the ethical challenges, big issue, and basically, how we're using these tools for teaching. So here are the answers.
1 minute.
1 minute, I have it. Okay, so for the first question, redefine education priorities, reinventing assessment methods, of course. Can you actually assess the student in what they know and if they have used ChatGPT or whatever else. Empowering lifelong technology and learning, that's a very big thing in the US right now. How we should incorporate it to prepare the students, basically compare the assignments. Give them the assignment, tell them to solve it with ChatGPT, without ChatGPT, give them the solution. Let's try to find out if this is the differences, because basically sometimes you're going to get garbage from ChatGPT. Foundational AI models emphasize human oversight and collaboration. How should students be done to handle ethical challenges? That's a very big thing. Basically, integrate ethics, encourage, explore the legal and social implications. That's very much a very important part. Develop critical thinking around, the AI outputs, and promote ethical decision-making frameworks. So these are the things that we are setting up right now in the universities. We have a very high level of ethics in terms of the AI, but we have to drill down. And the last one is how to prepare our faculty. Well, basically we discussed this a little bit before. Provide them training. You have to convince the older generation, like myself, of that you need to have that. Okay? Encourage exploration, experimentation, and make sure that you reward the people who are using it as a tool, rather than punishing them, especially when they're going after promotions and things like that.
Okay.
Yes, and these are some of the challenges that we can discuss later on if you need to.
Thank you very much.
Thank you.
Our next speaker is Vladimir Riabov, correct?
Yes, correct.
Correct. Russian, what is
Background Russian.
Russian, okay.
Yes.
You were born in Russia or in the United States?
33 years I'm here after collapse of Soviet Union.
Here is Greece, Athens.
Oh, no.
Yes, in the other two.
20 years ago I participated in the first conference of ATNR in Introduction to Information Technologies.
Yes. In May.
Yes.
In May.
Yes.
We still have it.
Thank
Your
you.
name is there.
Thank you very much.
We have 9 minutes now because we talked for 1 minute.
Okay. Yes. My approach is a little bit different. I consider us like part of academic part of humanity. And what are the challenges of humanity in whole, and what the technological approaches and the ethical approaches should be developed, applied to meet these challenges and face the reality. So I'll consider the global frame of universe after this shrinking this frame to solar system, to our planet, to our region and regions and countries, and the stupidity of the humanity to run wars, self-destruction. Now self-destruction is also visible, sensible in our non-cooperation with nature around us. So, and I hope that future technologies and our ethical behavior will accept these challenges, and as a humanity as a whole, we try to build some front to fight with these challenges, and might be it will be a mission for us and our fellows, our students, scientists, young scientists, and so on. So, universe. The first academic version of universe was based on geocentric universe concept promoted by Ptolemy and other famous scholars. So, what's important? That this technology, this model was based on their belief that if the heavens are divine and the gods created man, then the universe must be geocentric. And this concept almost for 2 millennia were dominant, accepted by church, and anything that contradicts this theory, model, was punished. So Copernic was in his final manuscript published in the day of his death in 1543. He wrote the book, 6 books concerning the revolutions of the heavenly orbs, and created the heliocentric universe concept. It's not enough. What is nowadays? The major and very great development was with the launch of James Webb Space Telescope and the discoveries, even few discoveries of this, I don't know how, device, enterprise, I don't know how to name it. So, particular exoplanets were found, and more important, this technology confirmed the age of our universe, but we're looking forward, not back. So, and cosmologists predict that in 10 in the power of 100, the entire universe will disappear. So, no, it's not probably the scale for our humanity. So, but nevertheless, now we shrink the scale, our solar system. So, great developments. Parker's probe was sent, and many discoveries. Another famous project, and my student participated very actively in this project, was NASA Cassini spacecraft to explore Saturn and its icy moons for 13 years, and on Enceladus moon, the ocean was found with a hot seafloor that probably had the best chances for life. So this is the schedule. Mars, I was involved in the first mission of Pathfinder. So, and so very beautiful exploration. So now solar. Solar is #1 source of energy for the life here. Let's study carefully this I don't know, object, I don't know how to name it. So in many publications I made these citations here. You may find the prediction of our soul. The sun is in the best time of its life now, and in probably 3.5 billion years, the sun will explode, increase in shape and became a red star with orbit, with radius of the orbit of Mercury. Of course, no life on Earth, nothing. So, and so after this it will shrink to white dwarf and black. So, study of sun, it's in Greek. Now, our Earth,
3 minutes?
3 minutes, keep slides. Volcanoes activities, very critical. Think about this nice grand prismatic spring in Yellowstone National Park, the largest sleeping volcano on Earth. what happens during this nuclear wars? Somebody is crazy enough to drop atomic bomb inside. Oh boy, okay. Now, extinction events of the Earth. I selected for research 12 extinction events for starting from 2,300 million years ago, major events, so reasons of catastrophes. No, I'll skip slides, hopefully will be available for everybody. More important, the last period for last century is known like the Holocene, Anthropocene extinction. The role of human kind in destruction of our environment, the speed of extinction rate is 1,000 times more than any previous extinction. Okay, the same story with catastrophe for plants, for like different famous events.
1 minute?
Yes. So, probably I should not talk much about First World War, Second World War, Nazi, just Vietnam War. What is this? Iraq War. You know better than me. So, a huge number of bases around the world. So, now arms sales, like a business with leaders at the company level, country level, and so it's a business. Destruction of nuclear wars and different related events like application of depleted uranium and so on, attack of atomic stations. So, what is the key here? Concentrate human resources on mutual projects, and there are several examples like Large Hadron Collider, Nobel Prize winner, International Space Station, and so on.
Thank you very much.
Let's concentrate.
Thank you very much. Our next speaker is Professor Katsutoshi Kawashima, correctly? Do you want me to repeat your name so you can check me if I say it correctly? Katsutoshi Kawashima?
Yes.
Yeah. Okay, you have 10 minutes to impress us.
Katsutoshi.
Is that right? Correct? Did I say correct your name?
Katsutoshi Kawashima.
Katsutoshi. What did I say?
Katsutoshi.
I hope it's not a dirty word in Japan when I said your name wrong.
That means gold.
We have many gods here in Greece. 12 in only.
Thank you very much. I'm very worried about the future of Japan. At the beginning of my math class, I gave a problem. Prove that the sum of an odd number and an even number is odd. Only about 20% of students answered correctly. University students. This is a weird solution. Many students struggle with basic sentence understanding. Example. Please answer this question. Alex is a name used for both male Alexandra is? Of course.
What is the name?
Alex
The
is a name.
nickname for Alexander is?
Alexander. This is a
Name is Alexander that changed gender.
but less than 40% of junior high school students answer this question correctly. 40%. I am worried about the future of Japan.
Then we should cry.
So, in my so reading skills are essential across the subject and skill can help, but only if students can read and we need to connect reading and STEAM in education. So, how are reading skills among children in your country? And what kinds of efforts are made to improve readiness?
No, you
That's all.
thank you very much. I didn't count.
I can continue.
No, I didn't count you because I knew that you saw. Okay, so I didn't count you. I knew that you was because I have seen his PowerPoint. Okay, our next speaker, it's okay. We'll save time for lunch, so we'll have more time to eat. Notice I didn't say more time to discussion. Our next and last speaker, I'll try the name and kill me. Nirusha Thavarajah.
Yes, correct.
From Sri Lanka.
From Canada, but born in Sri Lanka, yes.
Yeah, that's what is important.
Yes.
I'm Canadian, but I was born in Athens, in Greece. Not
Yes.
in Athens.
Thank you very much.
10 minutes to impress the one I'm going to count you because judging from Bala, I don't trust people from Sri Lanka.
Good afternoon,
It's a
everyone.
reputation effect, but you have to prove.
Thank you for the invitation to join this roundtable discussion. So the topic that I bring today to discuss with you is when molecules meet machine learning. I'm Nirusha Thavarajah from the Department of Physical and Environmental Sciences. I'm a chemist by training from University of Toronto. So why I chose this topic, just to give a little bit of a context. I teach first year chemistry to fourth year undergraduate chemistry, and my research is in the area of agrochemicals and heavy metal contaminants that come from agrochemicals. So there are two ways in which where I want to use machine learning as well as AI-powered platforms. One is to teach students how to visualize molecules from first year to fourth year. And in my research study courses, I want them to be able to really virtually interact with molecules, to visualize, run programs to see, for example, certain drug molecules fitting into, say, for example, certain signaling pathways. Can we use virtual reality goggles to actually have them play with these molecules to see different allosteric sites and active sites per se in certain proteins. So this is where it started, and our department recently opened what is known as a virtual reality lab, where they have VR goggles available. And by incorporating programs like Nano, which allows you to put in, for example, a bank of enzyme crystal structures into this program, it allows you to, by wearing the VR goggle, you can have your hands sort of play with this molecule and see how the ligand fits, what sort of intermolecular interactions you can have between the ligand and the allosteric site of an enzyme. And this will advance drug molecule development, as well as if you're trapping, per se, heavy metals from water using a particular hydrogel, what type of interaction is between that hydrogel and the heavy metal, how does it trap, what is the efficiency. So these are some of the applications that we can use machine learning in chemistry research. On the other hand, when it comes to in-class learning, for first year to say fourth year courses, we could also think about platforms that are AI assisted that can provide an adaptive learning environment. So so the students will be given a problem and they will solve the problem. And if they make mistakes along the way, the platform studies what kind of mistakes they're making. And then it will prompt them to, or it will scaffold the problem so that it prompts them the area of trouble. So this is where this all started. So about a few years back, I would say about 5 years ago, I started using a platform developed by Pearson Publishing. It's called Mastering Chemistry. And what it does is it has AI-guided practices. So it provides students with targeted feedbacks and remediation. It also has dynamic study modules, so it allows for students to adapt according to their performance, as well as it has chemistry diagnostics tools. So for example, if they're struggling with a certain mathematical component of that problem, it will give like personalized learning plans. So looking at Mastering Chemistry, is it truly a machine learning program? Well, it is mostly AI-based, but it's not a full machine learning. So what is sort of the difference is that it adapts to the learner, but it doesn't do anything innovative. So moving on to how can we compare Mastering Chemistry to some machine learning powered platforms for chemistry? You can see that there are a number of different categories, maybe of time I'm not going to read through all of them. But you can see when you look at the learning focus, Mastering Chemistry gives personalized instructions, feedback, and pacing. Whereas if you were using a machine learning powered platform like ChemProp or IBM RxN, it will predict analytics, molecular modeling, and retrosynthesis. So it's very, very creative, and it's also innovative. So it can give sort of examples like how can it predicts or proposes synthetic methodologies, for example, for a drug molecule. So student interaction, if you look at it, it's structured learning paths and adaptive quizzes with the Mastering Chemistry, whereas with the machine learning powered platforms, they can have exploratory tools with predictive simulations. So these are some of the things, and if you look at the limitations, for the Mastering Chemistry platform which we use, it has no real-time learning from new data, but for the machine learning one, it requires clean data sets and computing power. So it's more advanced, and we want to use machine learning and chemistry to predict, design, and optimize our chemical synthesis. And so these are the pedagogical themes that we want to look into: curriculum enrichment, technological content knowledge, teacher training, student engagement, and ethical awareness. As you can see that we need to have a number of different examples of this study in order to understand how to go about doing this. And the key challenges using ML or machine learning in chemistry is we don't have enough training, so we have to look into how to train us and our students. There is also curriculum misalignment, so sometimes you might not find machine learning concepts to necessarily fit the traditional way that chemistry syllabi is designed. Data privacy and ethics, so there is concerns about data collection, algorithmic bias, as well as transparency in AI systems, and then dependence on the pre-existing data. So the machine learning models require a large quantity of data. So like I previously mentioned, for example, if you're looking at enzymes, we need to have crystal structures of the enzyme fed into the machine learning so that it can actually say you designed a ligand and you want this to fit into a particular allosteric site. You need to feed in that chemical structure, and it'll run the program overnight. It will spit out like 10 different ligands that will have the best optimization in terms of fitting into the allosteric site. So it requires a large quantity of data to do this, and the tool complexity, as well as the infrastructure gaps and assessment difficulties.
2 minutes.
Yeah, thank you. So these are some of the suggested in the literature to tackle these challenges. So we need to have training, we need to identify the gaps and provide the necessary tools. One of the planned pedagogical interventions that we will do with our VR lab in DPAS is to use our virtual reality goggles and Nanome, as you can see here on the right-hand side. So this is how it looks. You can feed in certain enzyme structures into Nanome, and what you see there is that the student will wear the VR goggles and it will create an avatar in the screen, and then they can actually use their hands to sort of stretch and see how the ligand fits or the different sites in the enzyme. So this is a comparison between different platforms that we are thinking about using. So Nanome, ChemProp, and IBM RSN. And the research areas, as I have previously mentioned, you want to be able to apply this in molecular design and optimization, enzyme substrate interaction, reaction mechanisms, stereochemistry, chirality, ligand receptor docking. And for the research for the hydrogel synthesis, we want to look into its polymer network, how this can also be used in medicinal purposes like drug delivery, as well as tissue engineering, scaffolds, and stimuli responsive systems. And this is our summary. So as I have previously mentioned, we want to explore Nanome as well as ChemProp and IBM RxN in order to enhance our students' learning in classrooms as well as in the lab. Very much for your attention.